for having me. Thanks for to Letijil. I hope I'm pronouncing it correctly. Kevin, Cecil, and team. I'm sorry I don't have a really good introduction like Ukas just did with the champagne. So I will just drink water. But yeah, I hope it will be enough. I don't think you can see anything, right? There. Maybe this is not the right place to. Let me check. It is not. It is not mirroring. Oh, that's weird. It's like a second screen, not like a mirror. Interesting. Yeah, but yeah, I can send this over there. Yeah, yeah, you'll see there. Okay. Problem is that I will not see this myself. Okay. All right. No, that's fine. That's okay. No worries. Thank you. All right. So yeah. So in this presentation today, I'm gonna talk about a little bit about how to build schema first APIs or asynchronous APIs or event-driven integrations or event-driven architectures. There are many names for this. We're still I have the feeling that we're still defining this as a community. So yeah. Let me grab this. Also, must mention that this is my first in-person talk after 2 years, so it feels really weird now. Where is my chair? Where is my my screen? Right. So sorry. So my name is Fran Mendez. I work as a director, executive director. This is a really ugly name. For the Async API initiative, I also work as a director of engineering at Postman. And but basically, what I do is I do Async API full time. And how many of you know about Async API already? Okay, not many. I'm in the right place then. How many of you know OpenAPI or Swagger? Perfect. So, how many of you know about event-driven architectures? Okay, that is really cool. So then it's easy. It's Async API is OpenAPI for event-driven architectures. That's it. Bye. I can walk out. Yeah, so let me speak a little bit about the specification. What's the purpose of it, right? So many people are used to use Swagger, OpenAPI. I know many people will kill me for keeping saying Swagger. But yeah, OpenAPI for REST APIs. I'm sure that you used to use as well GraphQL schema language. So from the GraphQL, all the ecosystem, you have the schema language as well, and that's the specification, right? So those are for different kinds of APIs. So for event-driven architectures, or for event-driven microservices, or Internet of Things APIs, or streaming APIs, any kind of streaming API, actually any kind of system that is based on the exchange of messages, can be defined with Async API. I'm sorry for the sound professionals. I'm keeping doing this. So Async API is protocol agnostic, and I want to reinforce this. So as the same way that OpenAPI is HTTP is for HTTP and GraphQL is for GraphQL over HTTP, probably or most of the times. Async API is not bound to any specific protocol. Why? Because there are many protocols. There are many, and it's impossible that we choose one of them. Like if we go with Kafka, Then what about MQTT, and what about the WebSockets, and what about AMQP, right? That's or if we choose AMQP, what about the rest, right? So that doesn't mean that the information about the protocol in the spec is not important. We care. We care about the. I mean, let me explain it in another way. Like, just because it's protocol agnostic, it doesn't mean that the specification doesn't let you specify the little details of each of the protocols. You still can do it, right? So you get the power of each of them. So this is an example of an async API specification document. I hope it's readable. I try to make it as big as possible. I hope so. So yeah, if you're used to OpenAPI, I'm sure that this structure looks familiar to you. It starts with an async API field, like in OpenAPI. Then it follows channels, which is similar to paths in OpenAPI somehow. And then you can have like a list of channels, and there you can describe what your application, what the clients or the consumers of your API can publish or subscribe, right? So publish to or subscribe to, right? So there you can define what kind of message. So for instance, let me put it this way. I'm running a product myself, and I want to build an API that, an event-driven API that whenever I receive a sign up, I get a new user signing up in my product, I want to send a message to a broker, to a message broker like Kafka, like RabbitMQ, like Mosquito, whatever. And so other components of my architecture can get the notification that this actually happened, and they can react and do something accordingly, right? So there's a message. There's a message that I need to send to the broker, and there is a channel. And a channel, it's usually called a topic, a routing key, the event name as well sometimes, even though I find it weird, but it's also you can also find it there. And then there's a structure for your message. So this structure of your message can be defined, just like in OpenAPI. We use JSON schema internally, right? So you can use JSON schema to define your message structure. So, but this talk is not about async API, the specification. I really encourage you to look about a little bit about the spec, because I think it's a really interesting work that has been happening for the last 5 years already. So yeah, have a look. The thing is that this talk is about schema first types of APIs. How many of you know what schema first means in this context? Only one in the whole room? I'm amazed. That's really cool. So, well, I hope that many of you already, I think I asked before, that you were used to GraphQL. You know what GraphQL is and what the GraphQL schema is, right? Just to make sure, you know what GraphQL is and the GraphQL schema language is? Not many? Okay. So, thing is that when we develop for instance, a REST API, and we define it with OpenAPI, the implementation and the OpenAPI definition are usually decoupled or separated, right? So there is a risk that I create a new endpoint or change something on my API, and I forget to put it on the OpenAPI document. Or there's also the risk that I put it in my OpenAPI document, but I make a mistake. That also can happen. Or can also happen the other way around. I add something to my OpenAPI document, but I implement it incorrectly, or I forget to simply implement it, which is a weird case, but could happen as well, right? So they are both decoupled. So what happens here is that over time, teams tend to develop their APIs, and they have strict deadlines, right? Like they rush, they have to ship code faster, and updating OpenAPI or async API, it's a pain in the ass, to be honest. So it's like it's a stone in the way, right? And it's not required for the product to work. You can just ship your product with OpenAPI or async API. So that is a problem, because then you end up having documentation that is not strictly telling the truth. And the rest of the teams are thinking that this is the real truth. And that's a problem. And then things are creating more internal tickets or external tickets, saying like, hey, your API says that I can do this, but it's not really true. That's a problem, right? So in the end, what happens over time, and it happened to me in many companies, is they drop the OpenAPI file, or they drop the async API file, and it's a problem, right? You really need someone who's really interested in maintaining this documentation, or a team, right, to take care of it. So, is there, like, the question here is there a way to make the implementation and the definition, more tied together? So, is there a way that we can make it just so if we make a mistake on the OpenAPI document, or the async API document in this case, it gives us a warning or something like that, or an error, like saying, no, you can do this because the implementation is doing something different. And then that's the question that we get asked, right? I think, yeah, my laptop is set to save energy, so don't go to sleep yet. So yeah, thing is that at some point I was saying that I was asking myself, like, is there a way that we can tie things together? So if you investigate a little bit more GraphQL, you will see this use case. It's really the case of GraphQL and gRPC as well. So in the case of GraphQL or gRPC, you have a document that defines all your queries and mutations of your GraphQL API, and that's called the GraphQL schema, right? And then once you have that defined, you bind your code to your GraphQL schema. So what happens is that because it's strictly typed, if you commit a mistake in the code and return something different, or pass something different to your API, it's not gonna work. It's gonna give you an error, right? So can we do the same with event-driven architectures with async API? Well, I guess you know the answer, right? So the answer is yes. So cool thing about let me just highlight this first. Doesn't want to go back. Okay, not too much. I guess it's synchronous. Okay. So then, aside from the things that I just mentioned, there's also, like, if we can make it work like this, that we define things, we use the async API file as a configuration file, right? Which is what it is in the end, right? If we tie them together, then what happens is that our code will have less boilerplate. So all this code that you need to do, like, I'm gonna install this Kafka library, or framework or whatever, and I'm gonna instantiate the Kafka object and pass the connection details, and and subscribe to all the topics that I want to subscribe, and all this stuff, all this ceremony that we always do, every one of us, whenever we're doing implementing a Kafka API or event-driven service. I don't know, there are many names. So this can be avoided, right? This can be hugely avoided because all this information is on the async API file. So why would you need to do all this ceremony? Like, let's use the async API file to do this for us, right? Or to define these things for us. And yeah, and since we're using JSON schema, all the data is strictly typed and validated, right? So perfect, we have all the pieces. Now the only thing we need is a framework that could do this for us, right? Is the only thing that we need. So that's what I want to demo today here. I hope that I managed to make this demo well, because I'm not seeing anything here, so I'm only seeing it there. So yeah, let me check what I can do. Where's the mouse? All right. Not that bad. All right. So before I do the demo, I'm gonna show you what I want to do. Not this one. Damn it. I'm looking in the wrong place. Keeps happening to me. Yeah. All right. So look, as a demo, I usually in the workshops, what we teach is that let's build a really stupid and basic social network, right? For the sake of testing this framework, and it's also in the examples on GitHub on the Glee repo on async API, right? So this is a result of the demo, right? What you're seeing is a result. So we have like a kind of weird Twitter combined with Instagram or something like that. That's really weird. Sorry for the design. And let's just say that this is my profile. And I have some publications there. And you can see that my friend Łukasz Gornicki is not the same Łukasz, but he also likes to drink. So yeah. I guess it's common. So yeah. And I have the profile of Łukasz here. That is not supposed to be on the same computer, right? So Łukasz is seeing his profile or the social network from his point of view, and I'm seeing it from my point of view, right? So what I want to teach here is that what I want to show here is that, say for instance, you see that this first publication has 0 likes, right? In both, obviously. So if I click here, and that's demo time, is it gonna fail? I'm afraid. Looks like it works. Oh, no, it didn't work. I have to refresh, yeah, because the WebSocket connection, it's a demo, so yeah, it doesn't reconnect automatically. So yeah, it's 0 in both places, right? So if I click here, I get a like, and now the like is there, right? It's there. I think that's it. That's the demo, right? Now that's it worked. No, I'm kidding. I'm kidding. So that's the result of the demo. So what we did here is, I'm gonna explain now what happened here, right? What we have here is we have the browser sending messages to a WebSocket server, right? Saying like, Fran liked this publication, Lucas liked this or unliked or disliked. I don't know how to say that. And then once you have that, once the WebSocket server has this information, it's gonna somehow forward it to the MQTT broker. I'm using an MQTT broker here because it's really liked, but we're working right now on having support for Kafka, AMQP, and so on. And then because I have another service running, which is the notification service, that is subscribing to this kind of messages on the MQTT broker, the notification service is going to receive this message, and it's going to know that someone has clicked liked on one of the publications. And what it's going to do is it's going to send a message to Slack saying, hey, for instance, hey, Lucas, Fran liked your publication, your post, something like that. Pretty simple. Everyone follows? Okay, so it seems pretty simple. For the sake of the demo, I'm not sending to Slack because I will have to be configuring things here, and that's already a mess as it is. So yeah, let's keep it simple. Let me show you what I'm doing here. What I have here is just so you can see the inners of the demo, right? So I'm not even using a database. This is a JSON file that I'm using as a database, just to keep it simple, right? So I have the likes here, the ID of the post that has been liked, and the user who clicked liked, right? And then I have a bunch of users here. Well, a bunch. I have two. Lucas and Fran, and all the details, the Slack ID, blah, 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 all the, the images, the name, right? And a bunch of posts. Actually, 4 posts, which are the 4 posts that you can see here, right? So that's the database. So what's happening here right now? Let's have a look at the, well, let me also mention before, I have a front-end project which is done with Next.js, but I guess it's not related to this demo, so let's keep it out of the demo, right? And that is all, it is all this interface that you see in there. But I would love to have a look first at this WebSocket server. So the WebSocket server is here. There's a folder here, WebSocket server. That is this is the demo that is running right now, right? And I hope you can see it well. I think so, yeah. So yeah, there are a bunch of files here. How many of you are actually familiar with Node.js, or familiar enough, at least? Okay. So I'm using TypeScript. So Glee, the framework that we built to create these schema-first APIs, is using TypeScript. So we're gonna go down from the bottom, up from the bottom. So we have the TypeScript configuration, README, package.json, package.log.json, license. All of these are just pretty standard files that you find on any Node.js project. We have the async API YAML, first one that is not actually pretty common in Node.js. Git ignore, .env for environment variables, right? And we have here a functions folder, right? And we have lib here, but I'll explain later what it is. So we have actually something that, the only thing that is, let's say, that is weird or strange, that is not a typical Node.js project, is the async API file and the functions folder, right? So if we look at the functions folder, let's first look at this. Look what it is. So I try to keep it simple as possible, because this is a presentation and I know you don't want to be reading code on a screen during the presentation, right? But yeah, let's try to keep it as simple as possible. What's happening is there is a function. The name of the function is the name of the file. Unlike, dislike. I think it should be unlike. I should be correct in this English, but yeah. So that function is executed every time someone hits the like button, either to like something or to unlike something. That sounds weird. And we get the event. So the event is the information that we're sending. Which information are we sending to the whatever information that we're sending to the WebSocket, thanks, to the WebSocket server, we'll get it here. So we're gonna collect all the events that we want to send to the as a response to this. But first of all, we're gonna do something which is if the event that is happening is a like event, like someone is liking a post, we're gonna save it to the database, right? And we're gonna send something as a result, which is we're gonna send this this event here, this payload here, the ID of the post and the ID of the user to the post liked channel or topic to the Mosquitto server, to the Mosquitto broker, which is this one here. So we're gonna do this. It is describing this connection. We're sending this this message to the MQTT broker. Now, in the case it's not like, it is undoing a like, then we just remove it from the database, but we don't communicate anything to the broker. Just because we don't want to. so yeah. But then, also as a result, in every case, either when you click like or when you undo the like, we want to notify all the WebSocket clients. So I want to notify Lucas and every social network member that is looking at this publication, at this post, right? I want to communicate everyone that the count of likes has been updated, and the ID of the post that has been updated is this one, and now the total count is this one, right? This is just so I can refresh the UI on both windows at the same time, right? You saw that it was communicating. I clicked in one, and then the other one was reacting, right? So, yeah. I think it's pretty simple logic here, right? And then we just return this special GLI object, right? Which says that I want you to send all these events. Look at this logic. I'm handling WebSockets. I'm handling MQTT connections to Mosquitto. But where is the code? What is the code to actually spin up a WebSocket server? What is the code for MQTT connection for connecting to the client and everything? It's not there. It's not there. And I promise, like I just hide. I said that I was going to show you this. This lib file is just functions, a bunch of functions and logic, just so I could keep this file here as simple as possible for the demo. Right, but there is no logic, there is no code connecting to any kind of broker or spinning up a server, right? Everything is described here. So we have this file saying this is our social network. We have two servers, WebSockets and the Mosquitto, with all the details, right? We have a channel, which is the slash channel is like the root channel, right? Or no channel if you want. So in the case of WebSockets doesn't support channels or topics, so it is all in the same connection. So what it's saying is that you can publish this kind of events, like or undo like, and you can subscribe to the like count updated. So our UI is this client. It's sending like or dislike, or it's receiving like count updated, right? That is what is described there in this async file. And it says, this specific channel, it's only for WebSockets, not for the Mosquitto one, right? And then we have another channel, which is post/liked. And you can subscribe to this if you want. So the notification service will be subscribing to this, right? And the message that it's gonna appear there is described here below. Not really interesting for the demo, like it's a bunch of data that you need to pass, right? And it says that it's only for the Mosquitto server, right? So I think everyone is aligned here. If someone is really not like aligned with what I'm saying, or like is not following, please make a weird sound somewhere and just so I can notice it and explain it again. So yeah, was saying that. So this is the WebSocket server, but the notification service is exactly the same, right? But when it receives the event, it's just gonna send a notification to Slack. I hide all the logic for the demo purpose, but if we go to the lib folder, you'll see that there is a bunch of logic that I actually commented this morning, right? So so we can keep it simple. In case you like your own blog post, you get a really cool message. I'll show you. And then, in case you like other people blog posts or post, right? You get to send a notification to somewhere, right? To Slack in this case. So it's the same thing, and it has its own async API file for the notification service. It's only connecting to Mosquito. You see, there's no mention to WebSocket because notification service is only connected to Mosquito, not to the WebSocket server. So no mentions to WebSocket in this async API file, right? And that's it. And it's only subscribing, right? Meaning you can publish. That's a common misconception. So this notification service is subscribing to post liked, right? And yeah, and we're just saying that in the very moment we receive a message here in this topic, in this channel, we're gonna execute the onPost liked function, which is here, right? This one to send a notification. Cool. So we almost got it, everything, right? So let's just do it again. I'm gonna use my own profile. So I'm gonna undo the like and see what happened. Look, so it says an event on the slash channel was received from WebSockets. The data says that it's a post ID, user ID 1, and it's a dislike. And then it says information was broadcasted to the slash channel, right? Passing this information, which is post ID, total count 0, likes, and the type of the event is likes count updated. Notice that we have the type there because we can only have one channel on WebSocket. So yeah, so that is what we get. So because this event was broadcasted to all the clients, then Lucas also got it, and that's why it's updating to 0, right? So that is this part. But let's move to the notifications service, right? I'm doing a small spoiler there, right? So if I click on my own post, right, and I like my own post, oh no, sorry, this was Lucas. I'm using Lucas' profile. So if I click on my own post here, what I get is, it's great that you like yourself, but I'm not going to send a notification, obviously, because what am I going to say? Like, Fran liked Fran post? That's really weird, right? But if Lucas does it, if Lucas likes my publication, sending message to Slack, hey, and this is my Slack ID, Lucas Gornitzky liked your post. You can see it here, right? Obviously, the URL is not available to internet, but it could be, right? So yeah, so that's pretty much the demo. Let's just move, because we're running out of time. So let's just move forward. So yeah, I want you to just think about for a moment about what just happened here. I just defined all the communication in the async API files for each of the services, like what's going to be sent and what's going to be received, what's the shape of the messages and so on, what kind of protocol are we going to use, where are the servers or the brokers, all this kind of information, right? With this file, we can easily generate documentation quickly, right? Like with OpenAPI. But not just that. We have now the GLI framework that will read this information, and the only thing that it's asking you is to provide your business logic. Like, what should I do when I receive this message? If I receive a message on this channel, just give me this function. Like, what should I do? You write the function, right? obviously we cannot write the function for you. So it is like, it's custom logic, it's custom business logic, right? So what happens is, over time, there are, by the way, I didn't show it, but there are also mechanisms to send event, because right now what I saw is like when you receive an event, you can respond, right? You can react and send other events. But you may be you may want to be the first one to send the event, and instead of reacting to an incoming one, right? There are also mechanisms on Glee that lets you send an event on specific system events and application lifecycle events. So what happened here is that there's no boilerplate code. I just have business logic there, like what should I do? Should I send a notification to Slack? Should I store it on my database? What should I do, right? So over time, what happens is this code is gonna keep evolving, and if you don't add it to the async API file, it's not gonna work. And actually, I promise that it's not, well, I don't really have time, so. But I wanted to show you that if I change the async API definition, and whenever there should be a number, I put it that this will be a Boolean or string or something, Glee will fail and will show you the error that you're not sending the right information, either incoming or outgoing. It will validate for both. So you get validation out of the box as well. Plus documentation will be always updated, right? So yeah. Now, a little bit about the initiative, like really quickly. Last year, we joined Linux Foundation, so we're now a Linux Foundation project. I like, for the sake of transparency, we aim always to share everything we do in public, everything, right? And we keep always all the data in public, including the money. So this is the money that we have right now in the foundation. You can see it on our Open Collective profile. Right, and you can see where we spend it. You can obviously donate as well, but we're not, with this amount of money, we're not going to ask you to donate, because I think we're doing right. So we're fine for now. And let the company donate. So yeah, that is the money stuff that we have right now. And what do we do with this money? Because we can keep the money there forever, right? We spend the money in the community, right? We try to make it as community-driven as possible. I will say like it's fully community-driven. And this year, for instance, we got kicked out or not accepted to Google Summer of Code. And instead what we did is like, look, we have money, let's do it ourselves, right? So we're spending this money on 11 people on 10 issues, and we're giving each of them $1,500 grant, and you can find more information on the discussions, because everything is in public, including the design and of this mentorship program. And yeah, a great shout out to our sponsors, blah blah blah, right? Like Postman, obviously, and so on. Sorry? Oh yeah. Okay, no problem. Take a picture. So yeah, big shout out to our sponsors, and it's okay now. Yeah, no worries. So you probably notice that there are bigger logos on top, Postman and Solaz. So these are the companies who are dedicating not only money, but people working full time on async API. So in my case, my team at Postman, we are already 12 people working full time on async API. So yeah, and in the case of Solaz, I think it's already 2. So yeah, we got new tools. I just demoed Glee, but we have Async API Studio and the CLI, which is really cool, and I encourage you to have a look. And just a really crazy thought, that the crazy vision that we had a year ago, and for the vision of the Async API initiative for the next 5 years is that Async API becomes the #1 API specification for defining and developing APIs, like any kind of APIs. REST APIs, GraphQL APIs, event-driven architectures, or even asynchronous APIs, call it whatever you want. Does it mean that we want to compete with OpenAPI, GraphQL, and so on? No, we want to integrate with them. So if you have OpenAPI, if you have GraphQL and other formats, you can use it on Async API, and it will work with Async API tooling. And last but not least, November, we're celebrating our third Async API conference, and I encourage you to join. It's going to be virtual in the end, not in person. So yeah, I think that's it. Please join us. You'll see how transparent we are and how we encourage community. And yeah, thank you.
Thank you, Frank.
Sorry.
Thank you, thank you.
I hope I was on time.
Thank you, everyone. It's time for a lunch break now. So you can reach everyone in the main atrium and enjoy the meals.
Thank you.